Hello, in this video we're going to talk about measures of centrality. So this is when we have a bunch of data and we want to sort of summarize it with one number. Roughly, where is that data? Where's the middle of that data? You may have heard of this being called before averages, but average doesn't just mean one thing, it means many things. So there are three measures of centrality that we are going to study in this course. There are a couple more, but they have limited use, I would say. These are the three most popular by far. So they are the mode. The mode is the most frequently occurring value in a dataset. The median is useful for when you've got an order. So the median is a measure of centrality which says this is the value where 50% of the points lie above it and 50% of the points lie below it. So it's the point where if you split the data on this point, it would split it exactly in half. And then the final one we look at is the mean. The mean is good for ratio and interval data. And this is the value with the smallest distance between it and all other points. We're going to look at some examples of these and some examples where these actually might fall down a little bit. So if we got some data and we've asked, I think we've got 10 people here, we've asked them, what is your favourite animal? What's the most appropriate measure of centrality to use here to summarise this data? Well, we can't say 50% of the points lie above it or below it because there's no order and there's obviously no distance. So the only one we can use is the mode. So how would we calculate the mode? Well, we'd have to ask how many of each value is there, and the most frequently occurring value. So in this case, there were 5 people answered dog, 2 snakes, 2 cats, and 1 turtle. So the most frequently occurring value was dog. So the mode of this data set is the dog. Modes are not necessarily robust though. Look at this data set. What would be the mode now? 4 people answered spider, 4 people answered horse, 1 person answered bear, and 1 person answered giraffe. What do we do now? What's the most frequently occurring value? Now, actually, different textbooks will tell you different things here. Some textbooks will say there are 2 values of the mode. This data set has 2 modes, spider and horse. Some textbooks will say the mode here is undefined. Is it useful to say the mode of this dataset is spider and horse? It loses a bit of its use. Another problem with mode, look at this dataset. So in this dataset we have a load of colours. What's the most frequently occurring colour? Well, actually, the most frequently occurring colour here is red. All those colours, they either appear once or twice. Red appears 3 times. So the mode of this data set is red. However, would you be comfortable saying the most central colour here is red? It seems a bit unintuitive. So modes are good for nominal data and colours are nominal data. But we as humans, we also like to associate distances to colours when we shouldn't. And there might be other things we associate distances and order to where we shouldn't. For example, animals, we might say, horses, ponies, donkeys are all really similar, whereas, a bear is really different. Same with colours, you might say all the blues are kind of similar, but red is very different. Data-wise, they are all equally different. They are nominal data. It doesn't make sense to say they are more similar to each other than others. But we need to be careful that if we are using the mode to describe data that we as humans like to sort of assign distances to, then it may seem really unintuitive to a reader. We've looked at nominal data. How about ordinal data now? So I talked before about a Likert scale. Here's an example of a Likert scale where we're asking a question and we want one of these answers back. Strongly disagree, disagree, neither agree nor disagree, agree, strongly agree. Very often with a Likert scale, we'll actually use numbers to represent these things. So 1, 2, 3, 4, and 5. But we need to be careful actually that we don't see those numbers and assume we can treat those as ratio or interval data. We need to remember that those only represent ordinal data points. So what would be the most appropriate measure of centrality now? We could use the mode, but say a lot of people were in the strongly disagree and disagree. Say 10 people strongly disagreed and 10 people disagreed, but 11 people strongly agreed. The mode would be strongly agree, even though there were more people down that side. So now we need to think about the order. And how do we take order into consideration when we talk about measures of centrality? We can use the median. As an example, here are some responses to the question, do you agree with allowing Martians to run for MP? How would we work out the median? Well, we want to know 50% of the data lie below it and above it, so we need to first put all these in order. The first thing, put all our data in order. Now we need to find the more central value now it's in order. So we can start at the ends and start counting in. Start at the end and count in, until we meet in the middle. And we've met in the middle here at the value 2. And that is our median. The median here is the very middle value when we put these in order. And think back to our definition of median. 50% of the values lie below it, 50% of the values lie above it. That's exactly what that 2 is doing. So the median here is 2, which was disagree. This works with ordinal data when we have an odd number of data points. If we have an even number of data points, we'll end up with 2 things in the middle. And with ordinal data, we can't really do anything with that. But with interval and ratio data, we can. What is the median age of death of the Stuart monarchs of England? So there are 6 Stuart monarchs of England. James I, Charles I, Charles II, James II, Mary II, Anne. There are an even number of Stuart monarchs of England. So now when we want to work with the median age, we'll do exactly the same, but we're going to run into some trouble. Let's do exactly the same. Let's put those ages in order. Now let's start counting in from the ends to find the middle value. Ooh, now we have 2 middle values. Can we have 2 medians? Does that make sense to say we have 2 values where 50% of the data lies beneath it and 50% of the data lies above it? No, it doesn't. So we need to do something. And what we're going to do, because this is interval or ratio data, we actually have a distance between those 2 values, and we can choose a distance which is exactly halfway between them. And to do that, we can add them together and divide by 2. So in this case, 49 add 54 divided by 2 is 51.5. So the median age of death of the Stuart monarchs of England is 51.5. Think about, does that correspond to our definition of median? Well, 50% of our monarchs died younger than 51.5, and 50% of our monarchs died above 51.5. So yes, it does. But we can only do that with data where there's a meaningful distance between those 2 middle ones. With ordinal data, there isn't a meaningful distance between those 2 middle ones. So we do run into a problem there. With interval and ratio data, we can also use the mean as a measure of centrality. Remember, the mean is a value where the distance from it to all the other points in the data set is the smallest. And it doesn't necessarily have to be a value in our data set. How would we work out the value that minimizes the distance between it and everything else? Well, we have a formula for that. And here it is. So we read this as x bar. Now remember, we've been using bar before for sets to mean the complement of. But with a small letter, a bar would mean the average of, or the mean of. So x bar, the mean of the values x, is equal to 1 over n, where n is the number of data points we've got, multiplied by summing up all those values in the data set. So the mean of a data set is adding up all the values, dividing by how many there are. In this case, we can add up all our values, add up all our heights. There are 6 of them, so we divide that by 6, and that gives us 1.725 meters. Now, the mean is really useful for downstream tasks. It's really interpretable. Most people know when you say the mean, most people know what that means. But it does have some problems. Consider the next example. What is the mean salary in this business? So we have one person earning 18k a year, another person earning 20k a year, another person earning 191k a year, another person earning 17k a year, another person earning 20k a year, another person earning 19k a year. So we'll use exactly the same formula. Add up all the values, divided by 6, because there's 6 values, and we get 47.5k. Now, if there was an advert for this business which said, come work at our business, the average salary is 47,500 a year. That's really, really good. But then most people there are only earning 18, 19k. So here, even though this is the value which minimizes the distance between it and all other values, it's really skewed from being a true measure of where most of the data lie, a centrality, because we have that one outlying data point, probably the manager or the owner, who earns such a huge amount of money, whereas everyone else earns a lot less. So for skewed data, or for data with outliers, the mean doesn't really represent what we want it to represent. Let's summarise what we were talking about. Here are some things to think about for the mode, the median and the mean. So for the mode, it's used for nominal or ordinal data. It can be used for other data, but as soon as you get continuous data, it really doesn't make sense to use the mode. If you've got a load of heights, what is the most frequent height? Well, you can be 73.5 centimeters, you can be 73.75 centimeters. There's so many different values in a continuous data that the chance of anyone sharing the exact same height is tiny. So we wouldn't really use it for continuous data. So really we only use it for nominal and ordinal data. We do have this problem of multiple modes. Sometimes there are multiple modes and that is not very interpretable. Some people even say that if you've got multiple modes, it's undefined. It's not very useful at all when you have multiple modes. And if there's any sort of perception or order of distance, even though there's not a really, just like we saw with colour, if there's any sort of human perception to it, it sort of distorts the meaning of it and it becomes not useful. Even though mathematically and technically it's the correct thing to do, it's just not very useful if we, in our brains, wrongly assume things have got order and distance. How about the median? So the median was, again, useful for interval ratio data. We did see it being used for ordinal data as well. The problem with ordinal data, though, was when you've got an even amount of things, you can't really use it. So it's useful for interval and ratio data, really. And the mean, again, it's used for interval and ratio data. We can only use it for interval and ratio data because you need to have that meaningful distance between your points. And as we saw, it's really sensitive to outliers and skewed data. So when you've got outliers and skewed data, it sort of pulls the mean away from where we think of the centre to be, and it sort of becomes not useful anymore. But the way we define the mean, by being the value with the smallest distance between it and every other thing, okay, the way we define the mean means it's super useful in downstream tasks. So when we want to do some sort of statistical test, or when we want to use it in probability theory and so on, the mean is a really useful thing, and that's why it's so popular. And because it's so popular, most people know what it is, so it's really interpretable. When you say the mean height, people know what you're talking about. And don't underestimate the power of that. As soon as things are interpretable and people know what you mean, that's super useful. Some other things to think about, and really to talk about how we interpret averages. So this sentence is true. The Vatican City has 5.26 popes per square mile on average. The average number of popes is going to be the total number of popes divided by the total number of square miles. So sometimes, and you'll see this in newspapers a lot, not this exact one, but you'll see statistics like this a lot, where you need to think, how did they work that out before really being able to interpret it? What's written here is perfectly true. It just seems a bit ridiculous. Another example of something which is perfectly true but seems a bit ridiculous, so it just means we need to think more about how we interpret measures of centrality. Human beings have a mean number of arms that is strictly less than 2. And this is true. Why? Well, we're all born with 2 arms. Nobody is born with more than 2 arms, but there's plenty of people out there who, because of accidents or amputations and so on, have less than 2 arms. So if you add up the number of arms everyone's got divided by the number of people there are, you'll get a number that's less than 2. Number of arms on humans is a very skewed data set. Obviously, we've got most people in the world have 2 arms. Nobody has more than 2 arms, and some people have less than 2 arms. So it's a very skewed data set. So maybe the mean is not the correct thing to use here. Maybe we should actually be using the median. So here's just a taste of some things to think about when we try to interpret measures of centrality.